To do a system of nonlinear equations, if you've been given a graph, you can find your intersection points, and that makes it a lot easier. But algebraically, we still have to stick to either the substitution method or the elimination method. There's no calculator shortcut for this besides having a graphing calculator. If I have this system, x squared plus y squared equals 100 and 3x minus y equals 10, we're going to try the substitution method where we solve for one of the variables. If I take this bottom equation, it would be easiest to try to solve for y. So I have 3x minus y equals 10. And if I just add y to the other side, I have 3x equals 10 plus y. And then move the 10 over, I now have 3x minus 10 equals y. So that part's at least solved for y, and I can substitute it into the other equation. When I'm picking a variable to solve for, I'm not going to choose one of these that's squared, because then I have to square root both sides and I'd have a plus or minus situation. So I could have chosen x, but then I would have to divide by 3 and I'd have some fractions. Fractions might be inevitable at some points, but if we can avoid them, we will. So when I substitute this back in, it's x squared plus y squared equals 100. You want to make sure you use these parentheses whenever you're substituting something in. So the 3x minus 10 goes in those parentheses. We're stuck with something squared, a binomial squared. If you still benefit from writing that twice and multiplying it out that way, go ahead and do that. But if you recognize that square double square method of distributing this, that's fine. So I have x squared plus, and then we just distribute this whole thing. So 3x times 3x is 9x squared. 3x times negative 10 is going to be a negative 30x. And then we do it again in the middle, so I get another negative 30x. Negative 30 and negative 30 is negative 60x. And then lastly, negative 10 times negative 10 is positive 100. All right. So if I combine like terms, I end up with a 10x squared minus 60x plus 100 equals 100. And I can subtract 100 from both sides. What we end up with is just 10x squared minus 60x equals 0. There is a GCF there, so if I factored out a 10x, I'd be left with x minus 6. So that's our factored form, but if I solve those, I'm looking for the two solutions to that equation. So we use that zero product property that says 10x equals 0, x minus 6 equals 0, and we get our two solutions. So x equals 0 and x equals 6. But just like when we had our other linear system of linear equations, we need the point that is the solution. So x equals 0 is one part of the solution, but we are still missing the y value. Same with when x is 6. I can look at this graphically and see that this point should end up being 0, negative 10, and this other point should be 6, 8, but I can't get those y values without plugging in the x for it. So let's say I'd have 3 times x, which is 0, minus y equals 10. 3 times 0 is just 0, so 0 minus y equals 10. Leaves me with negative y equals 10, so y equals negative 10. Make sure that you put the appropriate ones together. So that was when I plugged in 0, which makes this solution 0, negative 10. Then we had another one when I plugged in 6, and I'll just do this over here. So 3 times 6 minus y equals 10. 18 minus y equals 10. And then let's see, negative y equals, if I subtract 18, I get negative 8. Divide by negative 1 makes that positive 8. So y is positive 8 when my x value was 6, so that point is going to be 6, 8. So we found both parts of the solution, 6, 8, and 0, negative 10. You're just going to want to write them out as your coordinates. So if I organize my work a little bit better, it would have been 0, negative 10, and 6, positive 8. The elimination method is similar to what we have been doing with the elimination method, but you're going to choose again one of the variables to eliminate, and then solve and plug that back in. So let's say I chose the y values to eliminate. Let's say I got 3x squared plus 2y equals 26, 5x squared plus 7y equals 3. And we're going to need to manipulate both of these equations. So I'm going to multiply the top one by 7 and the bottom one by negative 2. That would make both of these positive 14y and negative 14y. So 7 times 3 is 21, so I got 21x squared plus 14y. And then we need to figure out what is this 26 times 7, 182. Multiply by negative 2, I get negative 10x squared, negative 14y, and negative 6. We combine the equations so we see the y's have canceled out. And then that would make 11x squared equals 182 minus 6 is going to be 176. We've got to divide by 11. So let's see, 176 divided by 11 is 16. So x squared equals 16. Because we are square rooting, that means I'm going to have plus or minus the square root of 16, which is just 4. So I have plus or minus 4. Those are two of the x values. Now I need to find the y value that's associated with each one of them. So let's say I have 3x squared plus 2y equals 26. One of those x's is a positive 4. And we have 3x squared plus 2y equals 26 again. But the other x value was a negative 4. When I plug this in, I get 4 squared 16. 16 times 3 is 48. And then we just subtract 48, so 26 minus 48 is negative 22. 2y equals negative 22. So y equals negative 11 when we divide by 2. That gives me a point of 4, negative 11. The other point, I'm still going to plug this in here. Well, negative 14 squared is still 16, and 16 times 3 is still 48. So we really get the same thing. If I subtract 48 again, I'm going to get negative 22. Divide, I still get negative 11. So the other coordinate is negative 4, negative 11. Now this would have still worked if I had eliminated my x's first. You could have eliminated those, solved for y, but you would still plug y in to solve for both of the x values that we got. Graphically, we saw that those were points, negative 4, 11, positive 4, negative 11. And you could try plugging those back into your original equations. You'll see that it does work. So let's try a few out. You can pause the video and do them on your own, or you can do them with me. All right, for number 3, if you want to use substitution or elimination, either one's fine. I'm going to use elimination just to kind of show what happens here. So I will eliminate my y's since that's going to be a little bit easier. So let's multiply this by -1. That makes this stay the same. So x squared minus y squared, or y equals 2. The other one becomes -2x plus y equals +1. And when you add these together, be careful because the y's are going to cancel out, but these things are not the same. X squared plus -2x is not going to make a 3 or a -1x squared or anything. So that's just x squared plus -2x or -2x equals, and then 3. We get a quadratic equation. To solve a quadratic, we need it equal to 0 so we can factor it. If I subtract 3, I get it equal to 0. Now let's try to factor this thing. X squared came from x times x. We'll look at factors of 3, like 3 times 1. That would work to give me a -2x if we have a -3x and a +1x. So I'm putting -3 and a +1 there. We solve our equation using that zero product property. So x minus 3 equals 0, x plus 1 equals 0. So x equals 3 and x equals -1. Those are our two x solutions. We still want to plug that in and find the appropriate y value solution. So I can plug it into either one. Let's go to the top one. So 3 squared minus y equals 2. 3 squared is 9, so 9 minus y equals 2. We subtract 9 and get -7. And y is equal to +7. That was when x was 3. So that's my coordinate 3, 7. Then we plug in -1. So let's do it over here. -1 squared minus y equals 2. -1 squared is just +1, so 1 minus y equals 2 makes that -y equals 1 if I subtract 1 from both sides. So y equals -1. Y is -1 when x was -1. So that coordinate looks like this. So we do get two solutions here, 3, 7 and -1, -1. If you had plugged those into your original equation, just to kind of double check it, 3 squared minus y is 7, should equal 2, and it does. 2 times 3 minus 7 still equals -1. So we know that point works. We can try -1, -1. Just put it in parentheses. So -1 squared minus -1 does give me 2. And 2 times -1 minus -1 is -1. So that does work out. Okay, so for number 4, you can try using substitution or elimination, but really we can't use elimination at all. When you think about elimination, they need to be the same that we could eliminate, and y squared and y are not going to eliminate. X squared and x are not going to eliminate. So really we're stuck with this where we're going to have to use substitution. I could solve for either x or y. Either one of them is going to be just as easy. So I take x plus y equals 5. I'm going to solve for y by just subtracting my x over, so it would be 5 minus x. Now I can use substitution and say x squared plus y squared equals 4, and that y is 5 minus x. You can make that -x plus 5. Either one's fine, but you're going to end up writing it twice. So 5 minus x times 5 minus x, since it's squared. And if I distribute, we get 5 times 5 is 25. 5 times -x is a -5x, but we get another -5x on the inside, so that's -10x together. And -x times -x is a positive x squared. If I combine like terms, we see 2x squared minus 10x plus 25 equals 4. If I subtract 4, that's just 2x squared minus 10x plus 21 equals 0. And we would try to factor this if we can. So 2x squared came from 2x times x. Our factors of 21 are going to be 7 and 3. So I can try this out. 7 times 2, if I did this on the outside, 7 and 2 would be 14. 14 and 3 is not going to give me a 10. So maybe I put my 3 here and the 7 there. 3 times 2 is 6. 6 and 7 are still not going to give me 10. We could try 21 and 1, but what we end up seeing is that this doesn't factor. So we're going to have to do the quadratic formula. If I do negative b, I'd have negative 10 plus or minus the square root of negative 10 squared minus 4 times a times c, 21, all over 2a, so 2 times 2. We plug part of that into our equation. Our calculators are 10 plus or minus the square root of something over 4. Let's just figure out what goes inside the square root. So negative 10 squared minus 4 times 2 times 21 is a negative 68. Automatically what I'm seeing here is I'm going to have an I situation. So this is having some non-real solution in that one value. So x doesn't actually have a real solution, which means that this system has no solution. If we had gotten a real value that we could plug in, that would be fine and I could get the coordinates that way, but this actually has no solution. If we looked at this graphically, in Desmos you'd see a circle, and then the second equation is just a line, but it looks something like this. And you'll see that they never actually intersect. So that happens sometimes. It just means that there's no solution. All right, so you can practice the rest of these that are in the lab manual for some extra practice and look at the answer key to check your work.